Thank you. So today's topic will be, for the presentation will be the evaluation of edible proteins for the vitamin and soft fresh with cucumber. It is one of my research field on which I am working right now. That is the post-harvest management of horticulture crops, especially with the respect of fresh cut fruits and vegetables. So the things here I am going to present one by one, starting with the introduction. We very much the different type of problems which are associated with this fresh cut produces, and they are more susceptible to the deterioration than the corresponding whole vegetable due to you can say the exploration of more surface area to volume ratio to the environment. Next, please. So the basic two type of spoilages which are associated with this type of fresh cut produces, they comprises of physiological and microbiological. Among the physiological spoilages, we are very much aware like the browning of the fresh cut fruits and vegetables due to the oxidations and the enzymatic activities over them. And microbial spoilage includes the spoilage or the growth of the various type of pathogenic microorganisms over them that will be the harmful for the human health, causing the food type poisoning or intoxications. Next, please. So one of the preservation methods that have been associated with the project work, that is the utilization of edible proteins. Basically, these are the soluble formulations which can apply in the thin layer form directly on the food surface so that there will be a boundary between the environment and the food atmosphere. Its inherent properties should not get applied or to the get associated with the environmental or the storage conditions. Basically, they will act as a barrier to retard this oxygen, moisture, and the solute movement on the food surface. Basically, the major benefits which are associated with this type of edible proteins, that they can be consumed with the food, and they even can provide various additional nutrients in the form of like phytochemicals, antioxidants, and another type of anthocyanin procedures also. So these edible proteins basically have 4 or 5 potential uses, like they can seal the flavors which are present in the food in the form of preserving the volatiles. They can control the microbial load over the fresh cut surfaces due to their antimicrobial or antibacterial activities. They can reduce the loss of the moisture and the firmness from the food material, and they also retard the respiration rate. Next, please. So the study of the project comprised basically proposed to accomplish the 3 major objectives. We need to screen or evaluate the various antimicrobial effects of various edible proteins for the preservation of this fresh cut cucumber. And again, when it comes, we need to optimize the concentration of the respective protein and the dipping time of the cucumber slices in that protein. And lastly, after the optimization, we need to study the shelf type of that very coated fresh cut cucumber. Next, please. So starting with the first experiment was basically on the pre-disinfection, because we are very much aware the quality of the produce starts, it's getting deteriorated from the harvest, only from the soil or the irrigated water that we are using in the field. The initial only washing with the potable water and a disinfection pre-treatment on the fresh cut cucumber slices have been performed according to our previous optimized studies. One of my paper on this evaluation of the various type of disinfectant procedures for this fresh cuts we have analyzed, and it has been optimized like 100 ppm sodium hypochlorite solution in which the cucumber can be dipped for 20 to 23 minutes. And that can be a feasible step that can reduce the microflora up to a very great content for before the application of the edible proteins. Among that experiment, we have taken the 3 major aspects of analysis. First was the major concern, that is the microbial count. And we have taken the count before and after the treatment of this disinfectant. And we have analyzed the total aerobic rate count, yeast and molds count, and the total coliforms, along with the various upcoming Salmonella, Shigella, and Listeria pathogenic species. Among physical parameters, the weight loss and the firmness were the parameters that has been taken into consideration. And among biochemical properties, we have checked the total sugar content, pH, ascorbic acid, the titratable acidity, phenolics, their ripening index, and the total soluble solid before and after the treatment. Next, please. So here is the picture. You can see over here how the disinfectant treatment has been done for this fresh cucumber in the sodium hypochlorite solution. The raw vegetable cucumber was peeled and cut into the slices, and the slices were dipped in the 100 ppm solution, and then they will be air dried, and then they packed into the PTE food grade containers. Next, please. So these are the basic parameters that we have analyzed before and after washing, and from the table you can see the parameters like microbial count, like total plate count, yeast mode and coliforms. They have been reduced up to a very considerable significant change. These values are in the log CFE per gram of the fruit. Besides all the physical and biochemical parameters, including pH, TSS, firmness, phenols, ascorbic acid, they all reduced up to a very non-significant level. That indicates the inherent properties of the food has not been changed with respect to the disinfectant treatment with the 100 ppm sodium hypochlorite. However, the microbial count has been reduced up to a considerable amount, so that can help in increment of the shelf life before application of the edible coating. Next, please. So after that, the second experiment was conducted on the screening of different edible coatings of the different biochemical natures for the fresh cut cucumber. We have evaluated 6 different type of coatings like alginate, starch, chitosan, pectin, carrageenan, and carboxyl methyl cellulase. And the same way the coatings were prepared of different concentration and 1 to 5% weight by volume. And the slices of this cucumber has been dipped for 3 to 15 minutes, depending upon the standardized procedures available in the literature. And then they packed into the airtight containers, and they have been stored under the refrigeration condition of 5 to 7 degrees Celsius. And at the regular interval of 3 days, we have analyzed all the physicochemical and microbial parameters to check the efficacy of this edible coatings over the fresh cut cucumber to control the microbial load over them. Next, please. Now, again, in the figure 2, you can see over here the fresh cut disinfected slices. They were dipped, the fresh cut sliced cucumber, they were dipped in the sodium hypochlorite the first step. Then we prepared the 6 different type of coatings, and the coatings has been applied over the cucumber by the dipping procedure, and then they will be air dried for just 15 minutes. And ultimately, they will get into the PTE containers, and they were stored under the refrigeration conditions for the analysis. Next, please. From the table 2, we have been concluded our results. Like for the fresh cut cucumber, chitosan behaved as a very good coating when the microbial inhibition comes into the consideration. We have seen that at the day interval of 9 periods, even the storage day, the count of all the parameters like total mesophilic pellet count and yeast and mold count and the total coliforms, they have been under the permissible limit according to US FDA guidelines. Like 5 log value of TPC was permissible for the total plate count in the FDA, 3 log for yeast molds and 3 log for total coliforms. And here we can see the chitosan among all the coatings, the chitosan have showed a very significant reduction in all 3 types of microbial counts except, and at par results was also seen by the pectin, but majorly concerned the maximum reduction or the maximum antimicrobial activity of the chitosan was reported, and hence the chitosan has been selected as a for the coating for preservation or the having as antimicrobial properties for the fresh cut cucumber. Next, please. So in the pictures, you can also see how the reduction of this total plate count has been reduced. This is for the total coliforms, and this is the total yeast and molds count before and after 9 days of storage between the uncoated and the coated cucumber slices samples. These are the microbial counts that have been seen even after the 9 days of storage. The count are under very permissible limits. Next, please. Next, please. And similarly, the physicochemical parameters that has been analyzed at the 9th day of storage. Here we can see all the physicochemical parameters that has been taken into consideration. They changed non-significantly with respect to the coating, but the control sample usually have the variation in the biochemical parameters also. However, the coating, irrespective of the nature of the coating, it has been seen like the physicochemical properties have been retained up to a very good extent, and all the microbial, antimicrobial activities and the physicochemical characteristics have been maintained during over the storage period of 9 days. Next, please. And similarly, in the graph, the microbial count has been explained. We can see over here in the control sample, the TPC at the day 9, you can see it can shoot up to more than 5 log values. However, in the chitosan, it is the minimum besides taking all other proteins into consideration. And other counts also we can see in the control. Without coating, it has been reduced, increased up to the 4 log values in nearly, except the coated chitosan, which have only the value below the log 3. Other coatings are also having the log values less than the control samples. However, the major reduction was observed in the chitosan coating. Next, please. Then the third experiment was conducted according to the optimization, because the concentration of the chitosan in the coating has to be optimized for a period of a time of that how much dipping time has to be considered while dipping these cucumbers in the respective coating. So concentration of the edible coating that we have selected chitosan and the dipping time in that coating, we have taken a statistical software help. We have optimized both the parameters using the response surface methodology following the design expert software. And from here, we have taken the 2 levels, low and high levels, between the range of 1 to 5 for the concentration of the protein and 3 to 15 for the dipping time, depending upon the literature available in the Google papers. Next, please. And after the designing of that experimental plan, statistically, we got 3 runs in which the different concentration levels and different dipping time levels has been considered, taking 2 extreme into consideration beside our lower high range. You can see over here in the concentration minimum was 0.17 only, and the highest concentration was the 5.8. And among the dipping time, the lowest time was the 0.5. And the highest was the 17.48 minutes. And these extreme values have also been considered. We have executed all the trials for the all 13 runs, and we have taken like 3% chitosan coating in which the cucumber has been dipped for the 9 minutes. Similarly, all other experimental plans, all 13 runs have been executed, and the responses has been taken into consideration in the form of physicochemical as well as microbiological parameters like pH, TSS, firmness, sugars, total plate count, yeast mode, and polyphenols. And among all these, the combination studies, we have seen that 1% chitosan coating and in which the cucumber has been dipped for only 3 minutes, that showed the maximum microbial inhibition in the all type of microbial parameters. And the parameters which are taken for the physicochemical characteristics, they are very much in respective of the control parameters. That's why the 1% chitosan concentration in which the cucumber slices have been dipped for 33 minutes, 3 minutes only, that has been considered as the optimized concentration. Next, please. So these are the model values which have been given by the statistical software analysis. We can see over here the model values of all the parameters are significant along with the adjusted and predicted R-squared value in agreement with them, and a p-value of less than 0.05. It indicates a very good fitness of the model. That means the executed runs, 13 runs have been executed very well, and all the predicted and the actual values come in accordance with the software. Next, please. These are the 3D surface graph in which the interaction of all the 2 parameters for the 3 microbial counts has been taken into consideration. You can see over here the TPC count along with the taking the concentration dipping time and the concentration of the coating into existing. We can see over here at a concentration level of 3, the maximum reduction has been reported. And for the dipping time also, there is a straight line. However, dipping time, it's not significantly have a major effect on the TPC count. But for the yeast mold, it is also a straight line, but beyond going the 12 minutes, the yeast mold counts has started to be increasing due to the presence of certain sugars in the coating as well. So that maybe the yeast mold have been taken substrate for them, and multiplication of yeast mold have been started over them. Similarly, for the polyforms also, a dip in the graph has been noted over here in the minimum range of near about 12% of the dipping time. And the concentration also, the effect of the concentration of increasing beyond up to 3% or the 4%, the similarly non-significant decrease in the coliform count has been reported. Next, please. So these are the optimized parameters, concentration of 1 and the dipping time of 3 to 5 minutes. And the validation of these results have been performed at a higher scale, that is the 5 kg scale. And we have noted that all the parameters, physical parameters and the microbial parameters are in accordance with the statistical software analysis with the desirability of near about more than 90%. Next, please. Then after the optimization of all the parameters and all selection of the protein, we have concluded a shelf life studies experiment, and we have stored the fresh cut cucumber slices after the disinfection treatment in the sodium hypochlorite, followed by the 1% phytosan coating for the cucumber slices for 5 minutes, then storage under the refrigeration condition. And we have seen over a period of 12 days, it has been noted all the parameters like this pH, titratable acidity, firmness, the total sugars, they have been reduced non-significantly in the coated cucumbers. However, the loss of some phenols, ascorbic acid, and the racemic index has been, or the weight loss has been reported, but that was comparatively very low as compared to the uncoated samples. And we have also performed the sensory analysis for the consumption of fresh cut cucumber slices with the coated and the uncoated one. And it has been seen even up to the 12 days of storage, a good score of 6 out of 10, 6 out of 9 has also been attained by the coated fresh cut cucumber slices. And on the 0 day, both the cucumber slices, the controlled one, which was the fresh at that time, and the coated one, they scored a very good score of 8. That means the coating, edible coating itself do not have any kind of taste in it. However, the consumption is approximately equivalent to the fresh cucumber that we are eating. Next, please. And these are the microbial counts on the respective storage period. For it has been seen like the uncoated sample, they started deteriorating and they have surpassed the limits of the microbial limits on the 6th day, that TPC go beyond the 6 log, yeast molds go beyond the 4 log, and the coliforms also. However, the coated sample, they retain their properties in the terms of microbial load up to the 12th day. And the significant differences are also been reported among the coated parameters starting from the 0 to the 12th day. And the microbial count were still in the permissible limit of 5 log, 3 log, and 3 log for the total plate count, yeast mold count, and the coliform count respectively. And they will be fit for the consumption at even the 12th day of storage. Next, please. So here we can conclude all the research of that the disinfection pre-treatment of fresh cucumber with the 100 ppm solution, maintaining the dipping time for 23 minutes at 10 degrees Celsius, it can reduce the microbial load over the fresh cut cucumber up to a considerable level. Among the 6 different coatings which have been evaluated, the chitosan shows the maximum % log inhibition of these microbials with respect to the other coatings. And optimization of the coating conditions of this chitosan coating resulted in the optimization level of 1% in which the cucumbers can be dipped for the 5 minutes, that show the minimum alteration in the physicochemical parameters and the maximum inhibition of the microbial growth. Validation were performed at 5 kg that showed desirable results along with the software. And shelf life study shows that the pre-treated chitosan coated fresh cut cucumber slices can be consumed up to even 12th day with all their physicochemical properties and sensorial characteristics, retaining their microbial load under the acceptable limits. However, the uncoated samples, they have only the shelf life of 5 to 6 days, and beyond that, the microbial limits exceed the acceptable guidelines as per the USFDA as well as FSSAI, along with the deterioration in the physicochemical characteristics. Next, please. Thank you.